So in this session, we will mainly discuss on octet configuration. If you see every element starting from, you know, carbon onwards, carbon, nitrogen, oxygen, fluorine, okay, and then comes neon. All of these elements are unstable in their atomic forms. So they are not stable in their atomic forms. What I meant to say, carbon's configuration is being 2 and 4, right? While nitrogen is 2 and 5, oxygen is 2 and 6, and fluorine is 2 and 6, 2 and 7. Carbon would always be ready to make itself to become either 2 or it wants to become 2 and 8. Nitrogen will want to always become 2 and 8. Oxygen will want to become 2 and 8. Fluorine wants to become 2 and 8. Okay? Carbon trying to become 2 is very rare. So we will mostly see this is the new configuration which it is. So if carbon has to become 2 and 8, this configuration is something which it has to get. But on the valence shell, it has only 4 electrons. What do we expect this to do? So from here to here, if it has to come, it has to accept 4 electrons, correct? When it consumes 4 electrons, then in the outermost shell, it would have 2 and 8 configuration. Since it is consuming 4 electrons, it would become an ion and it will become 4 minus. So carbon usually, which is 2 and 4, it would become 2 and 8 now. Similarly, nitrogen, if it has to become 2 and 8, then it has to accept 3 electrons. That means it would become 3 minus. Oxygen, if it has to become 2 and 8, it should accept 2 electrons, which means it should accept 2 electrons. Similarly, fluorine, if it has to become 2, 8, then it must accept 1 electron, hence it will become F minus. So I hope you understood the logic of how these atoms are actually becoming ions. Right? The reason for these elements to become ions is because they try to attain octet stability, octet configuration. Octet configuration. The octet configuration signifies to least electron repulsions, least electron repulsions, and symmetrical distribution of charge. So whenever an element is getting octet configured, it means it is having least amount of repulsions once it has become 8 electron system, and it might go for symmetrical distribution of the charge over the surface. The other day we discussed about this, see, like this. Okay? You can say this is a completely symmetrical way of distribution. So to attain this type of a distribution, right? So these elements, these atoms are trying to get 8 electrons in their system. I hope you understood that. Yeah.
Yeah.
Correct. So if these elements try to attain this octet, they are becoming ions. So you can see carbon is becoming C4 minus, okay, N3 minus, oxygen is becoming O2 minus, F minus, and neon is already very stable, correct? So these elements which are trying to have same electrons, see they have different protons, but same electrons.
Bobby, just 1 minute. Stop.
So if you see all of these species, okay, the species which I have put here, they all have different protons but same number of electrons, because now they have 10 electrons each, correct? All of these elements have 10 electrons each. So these type of species having different protons but same number of electrons are called isoelectronic species. So these are all isoelectronic species. Got it? Now, for instance, if you see aluminium, okay, if you see carbon, I'll take few examples. Al3C4. Here, it is three species of aluminium like this, and Al4, Al4C3. Got it? Here you would see 4 aluminiums with +3 charge, while 3 carbons with -3 charge, or -4 charge. Is this clear? Here, aluminum is also completing its octet. Okay. Why aluminum is completing octet? If I just recall about aluminum, aluminum was supposed to be 2, 8, and 3. Right? It is the configuration of aluminum. Atomic number of aluminum is 11. Right? So 13. So it is 2, 8, and 3. So if I remove those 3 electrons, then it will get an octet configuration 2, 8. So if we remove these 3 electrons, that means it is gaining positive charge. So it will have +3 charge on it. Correct? So aluminium will attach +3 charge on it. Correct? On the other hand, if you see carbon, carbon was already -4. Correct? So therefore, if you see, both of them have 2, 8 configuration now. 2, 8 configuration. Correct? So one is a positively charged species, the other one is a negatively charged species. So they would definitely attract each other. Okay, and the overall charge of a molecule should always be balanced. So you can see here, the overall charge here is how much? +12, and overall charge here is -12. It is balanced or not? Got it?
Yeah.
So for every salt, every molecule, usually the charge of the positive species and the charge of the negative species should always be balanced. So this is how carbon can exist. So it could exist with aluminium, and we call this as aluminium carbide. It's called aluminium carbide. Similarly, if I take Na3N, this is sodium nitride. Okay. So how is this? See, sodium, you have 3 sodium with plus and N with 3 minus. Now see the overall charge here also, it is +3. Nitrogen has -3. If you see the configuration also, this is 2,8, this is 2,8. Are you understood how the configuration is 2,8?
Yeah.
Yeah, because sodium has 11 electrons. If you remove one electron, it would have 2 and 8. Correct? Nitrogen has 2, 5. If you add 3 electrons, it will become 2, 8.
Okay.
So these two can combine, and this way they can form sodium. This can form sodium nitride. Right? Now suppose if at all I give you some elements, right? I'll give you 3, 4 elements, and I'll give you 3, 4 uh, atoms and ions. You have to determine what kind of a molecule they can form. For instance, if at all I have sodium, magnesium, aluminium, and silicon, let's say, okay, and I have carbon, nitrogen, oxygen, fluorine. Right? I want you to make molecules like this: NaXCy, NaXNy, NaXOy, NaXFy. Now, in all these cases, what should be the X and Y, right? Depending upon what charge they get. Okay. So now, for instance, if at all I have to make sodium and carbon molecule. Suppose I give you sodium, I give you some amount of carbon. What kind of a molecule do we expect this to form? So for this, always check what is the configuration they can have. You know, this is 281. This is
Yeah.
original configuration. This is 282. This is 283. And this is 284. Right? Carbon, on the other hand, is 2 and 4. This is 2 and 5, 2 and 6, 2 and 7. So if sodium has to get the octet completion, if sodium has to complete the octet, what it should do? Sodium should become Na plus. Okay, if it becomes Na plus, now the configuration will be 2,8 because it will lose one electron.
Yeah.
If magnesium, check out, it will become Mg2 plus if it loses 2 electrons. Aluminium can become Al plus 3 if it loses 3 electrons. Silicon can become Si plus 4 if it loses 4 electrons. These are the ions sodium, magnesium, aluminum, silicon can form. Right? Are you getting this? The other day also we discussed this. Sodium could also get Na minus 7 by taking 2, 8 and 7 electrons. 7 electrons, taking 7 electrons, losing 1 electrons, which is more favorable. Just losing 1 electron.
Losing one.
Correct. So the obviously sodium would never take this route. It would always intend to take the route where it can give least number of electrons. Okay. Right. Same way, carbon. Well, carbon is always in a fix, but let us see if it becomes minus what it would become. Just now we have learned carbon can become C minus 4, nitrogen can become minus 3, oxygen can become minus 2, and fluorine can become minus 1. Now, if you have to combine sodium and carbon and make a molecule, one thing we must know that the molecule should have the overall charge to be 0. That means it should be neutral. So, how many sodiums for every carbon, which is minus 4, and sodium, which is plus 1? Correct? So, you simply cross multiply with their number of atoms. So, what do we have here now? Na4C. That will be the molecule which you can get. Same way here, it is Na plus and N minus 3. So what do I get? Na3.
Na3.
Similarly, here what do I get? Na plus and O minus 2. So which means Na2
Na.
O. This plus 1 or plus is same. Okay. Here also I have Na plus 1 and F minus 1. So what do I get? NaF. Got this? Like this, if we can do it with magnesium, aluminum, silicon, let us see what are all the compounds I can get. If we do it with magnesium, magnesium is always going to be plus 2. Okay. So if I combine that with any of these four, that is C minus 4, N minus 3, O minus 2, and F minus 1. So what do I get here? Mg2C
4.
and Mg3N2.
3 and 2.
Correct.
Yeah.
Here I'll get Mg2, MgO, simply MgO. Because it is 2:2, the simplest ratio is 1:1. And here it will become MgF2.
F2.
So this is how you should be able to figure out what would be the molecule. Okay, beta? Same way, if you see, like how you can see magnesium, if you can see aluminium. Okay. Now you can tell about this. What are the types of molecules you can get? If it is with carbon, we just learned. What do I get? Al4C3. With nitrogen, what do I get, beta?
Al3N2.
N3, na? 3 and 3.
Al3N. Yeah.
So it would be 1:1 ratio.
Yeah.
Next, if it is with oxygen minus 2, then
Yeah. Al2O3.
Al2O3. Then if it is with fluorine, Al.
Al3. Al3.
Very good. Okay. Now let us see that with silicon. If it is with silicon, with carbon -4, nitrogen -3, oxygen -2, and fluorine -1. Now tell me, first one, what do I get? SiC,
And C.
right? So it will simply be SiC. Next one is Si3
S.
and 4,
Si4.
because this is +4 here. Next one is Si.
SiO. Si2OH.
So it is
Si.
2 and 4, no? So it is 1:2 ratio.
Okay.
So it is actually coming as Si2O4, barabar. So that is nothing
Yeah.
but 1:2 ratio only. With fluorine, what do we have? SiF4.
F4. Yeah.
Right? So like this, you should be able to figure out what would be the molecule that can come. Okay.
Yeah.
So all these elements, we got to know how their molecules can be formed. And in a molecule, if you see these numbers, they are simply balancing the charge. Got it? Now, whatever we have discussed, all these molecules we have discussed, considering they are ionic. Okay? Considering these are all ionic compounds. There are compounds which are covalent also. So above, write down that, above compounds which are formed are ionic forms. They are ionic forms. Right? Sometimes, if you see, you have certain molecules like CH4, you have CO2, right? You will have CF4 also. You will have NO2. You will have N2O5. You will have N2O4. Right? You will have O2F2. Right? Now, all of these compounds, these are all covalent compounds. Covalent compounds. Okay? Here, there is no complete charge forming on them. Instead, they are sharing the electrons. For instance, I'll show you one of them. See, carbon first orbit. Suppose if this is the first orbit of carbon. Carbon's first orbit has 2 electrons in it. Let's say these are those 2 electrons. Then it has second orbit. Then it has second orbit here around it. And in the second orbit, we found that it has 4 electrons. So let's say these are those 4 electrons. 1, 2, 3, 4. How many more electrons carbon can accommodate? Can accommodate another 4 electrons. Correct. So instead
Yeah.
of directly taking away electrons which are available outside, it is approaching 4 hydrogens from 4 different directions. And what about hydrogen? Hydrogen has only one orbit here, correct? And in that orbit, you have 1 electron in it. This is the status of hydrogen atom. Correct? So if you see that hydrogen atom is coming this way, imagine there are 4 hydrogen atoms in all of this. One here, and one here. They 4 are approaching. Right? Now carbon, instead of taking away electrons directly, because it can't take away electrons directly from all these hydrogens. Instead, what will it do? It will say, why don't we share electrons? Okay. So what does carbon do? Immediately, it will arrange itself such a way that one carbon is aligned here and one carbon of uh, so you can see here, so one oxygen will be aligned on this, one electron will be aligned here, one electron will be aligned here. So these 4 will start sharing with each other. So what is happening here? Now this electron from here, 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 this electron and this electron. They are approaching each other and they are coming to a compromise that these electrons, right, will be shared. These two electrons, these two electrons, these two electrons, these two electrons will be shared by both the atoms. So now carbon would have a status something like this. Carbon, it has first orbit. First orbit has no involvement in the bonding. But now, if you see the second orbit here, this is the second orbit of carbon. The second orbit of carbon, now it has two electrons here, two electrons here, two electrons here, and two electrons here. These two are not participating, which were in first orbit. And this is hydrogen's first orbit. If you see, this is hydrogen, okay, and this is its first orbit. Right? This is the hydrogen's first orbit. So hydrogen's first orbit is something like this. Correct? So now hydrogen's first orbit would be here. One hydrogen's first orbit would be here, and what would be here. So these are all hydrogens. So both of them are sharing with each other. Now count the total number of electrons in carbon now. If you see 2, then 2, then another 2, another 2. So how many we are getting? 8 electrons. So in the valence shell, it has got 8 electrons in valence shell. Valence shell, right? Which means it is an octet complete configuration. Octet complete configuration. Yes or no? Right? So this is how carbon would try to get the octet completion and become stable. So there are two ways an atom can get stabilized. One is by taking away or giving away electrons, that is by ionic way. The other one is by covalent ways. Covalent way is nothing but sharing of electrons. So either by sharing or by completely accepting or giving electrons, you can get various compounds. Is that okay? You got
Yeah.
any? Now, since we know there are certain compounds that are forming, okay, our next objective is to understand, well, we have compounds, we have atoms, we have compounds, which we call it as molecules also. Atoms, molecules, compounds, these are all something which we know. But how do we name them? That is an important aspect. Right? Because suppose if you have CO2, we call it as carbon dioxide. So is there any particular rhythm in it? Is there a particular pattern in it? Are there any particular rules we are following to name a compound? This is something which we need to know. Okay. So next one is about naming compounds. Naming the compounds, or you can also call it as substances. Correct? So first of all, to name them, we need to categorize these substances into three kinds. So all the substances around us, we can categorize them into three kinds. They are acids, bases, and salts. So everything right from the food which we eat, we consume acids, bases, and salts. Correct? So every compound around us, every substance around us, we can categorize them into these three broad way. Broad way, we can categorize them into these three aspects: acids, bases, and salts. So our idea should be about understanding this terminologies. What is an acid? So by simple definition, acid is something which increases H plus ion concentration in solution. Anything which can increase the H plus ion concentration in the solution is called an acid. Okay. Suppose if I give you HCl, if I give you HCl, right? If it is written this way, okay, is HCl an acid? Is
Yes,
HCl an
it's an
acid?
acid.
Okay. Now it's a very
Yeah.
tricky question. The minute I ask you HCl, first of all, you need to see how it is represented. HCl can be represented as this. It can be represented as this. It can be represented as this. What does this bracket represent? Tells us. When we write something
Okay.
in bracket, L means it is in liquid state. G means it is in gaseous state. AQ means
Yes.
aqueous, correct?
Aqueous.
Yeah. What do you mean by aqueous?
Aqueous. Um.
It means if at all I have a
Sorry.
glass of water, maybe I have added a pinch of HCl or a drop of HCl, okay, or just a teaspoon of HCl, correct? Then HCl is present in large amount of water. Then you will write it as HCl in aqueous. Are you getting it? Yeah. So when we write it this way, whenever we use these terminologies, for example, HCl can be solid also. Now, whenever we write this representations, okay, either this, or this representation, these representations are pure forms. Pure forms. That means they are pure solution, pure substances. There is no mixture in it. We have not added water in it. Are you getting it? So when you write HCl in bracket L, which means it is a pure HCl liquid. Right? Same way,
Yeah.
if you have HCl in bracket gas, that means it's a pure vapors of HCl. There is no other contamination, no other gas percentage. But the minute when we write HCl aqueous, right, it means it is HCl present in large amount of water. Is present in large amount of water. Okay. So now it has become relative. That means in an aqueous form, that means when you have water in water, how HCl is behaving. That is something which we need to understand. Okay. So suppose if at all I give you two test tubes, let's say this is test tube 1 and this is test tube 2. First test tube, let's say I said this is HCl liquid. What does this mean? This is a pure liquid of HCl. It's a pure form. But if at all I say this HCl is present in aqueous solution, it means there is water present in it. This is how it exists now. Okay. Then we write this as H2O aqueous. Got it? So what has happened now? HCl was very limited amount. We added to large amount of water. Right? So we took some few drops from here, few drops of HCl and added here. Then this has become, sorry, HCl, H2, not H2, HCl. So it has become HCl aqueous. Okay. So this solution now is become acid. This is nothing. This does not have any definition. Acid is a relative definition. Anything which we say it as an acid must be relative to something. Okay. In a solution, if it increases H plus, then we call it as acid. So what is HCl doing? The minute you add it to water, it is releasing that H plus. So which means if you see HCl in infinite amount of water, because I am adding large amount of water into it, so it is becoming H plus aqueous plus Cl minus aqueous. Okay. So in a solution, what happened? Large amount of H plus has increased. Ritu, are you understanding that?
Yeah. My
Yeah. Have you understood what I'm saying so far?
Baba, your voice is breaking.
Can you hear me now? Can you hear me now?
Yeah, now. One.
Check your connection once. No, I have full connection here.
Hmm.
Okay. So basically, acids can be categorized into two forms. Let me repeat that again. One is Hydra acid, the other one is Oxyacids. Okay. Hydra acids. Now, these elements which I have written, phosphorus, sulfur, chlorine, silicon, bromine, iodine, they usually be central atoms. Central atoms. Okay. Central atoms. You can see sulfur is in the center here. In the entire molecule, if sulfur is at the center, you call it as the central atom. Yeah. So these elements would be always representing central atoms. They will always be central atoms. Now, if let me tell you what are hydra acids. If hydrogen is directly connected, is directly connected to central atom, okay, then we call them as hydra acids. Hydra acids. For example, H directly connected to fluorine, H directly connected to chlorine, H directly connected to bromine, H directly connected to iodine. Okay, H two hydrogens directly connected to sulfur, two hydrogens directly connected to selenium. Okay, so similarly, well, we have a lot of examples. I'm just stopping it. Okay. So if you write this as a molecule, what is it? It is HF, HCl, HBr, HI, H2S, and H2Se. These are all the molecules. Are you getting it? Correct? No, these hydrogens are directly connected to the central atoms. That's why they are called hydra acids. I hope you understood what is direct acid. Direct acids are all hydra acids and they are directly connected to the center. Okay? Sorry. A few more acids like that which are present are HCl, HCN. It is directly connected to Cn. Okay. Now, good part of naming, right? Like how we have a family name, right? Like we have a family name. These are also a family of acids, and all these family of acids also have a family name associated with it. Right? So all hydra acids will end with a suffix name as ic acids. They will always end with ic acids. Correct? Let me elaborate. Suppose if you have HCl, what do we name it now? This is named as hydrochloric acid. So this family name will be continued. They are all ic acids. So you can guess what should be the name of HBr then. The
Bromide.
hydrobromic acid. Similarly, if you have Hi, it is hydroiodic acid. If you have HCN, CN is cyanide, so it is called hydrocyanic acid. Okay. H2S, it has both names. Hydro, because there are two of them, you can completely call it as hydrogen sulfide, or you can also call it as hydrosulfic acid. You can also call it as hydrosulfic acid. Are you getting it?
Yeah.
I hope you understood how to represent the Hydra acids. Yeah. Now, one thing, you have heard about an acid-base reaction. Correct?
Yeah.
Suppose if I take HCl aqueous, we know this is called as acid. And if I take NaOH, we call it as base, right? And an acid and a base, if it combines, we know that it will create a salt.
Yeah.
So NaCl is salt and water, right? This is what we get, right? So
Yeah.
HCl plus NaOH is giving NaCl and H2O, where this is an acid, a base, salt, and water. Okay, correct, beta?
Yeah.
Now, the name of the salt will always be dependent on the name of the acid. Understood? What is your acid's name? If the acid name is ick, and if it's a hydra acid, and its name end with ick, got it? Then the salt name will always end with ide. That's right. If it is an ick acid, a hydraic acid, then the salt name will always end with ide. Then what is the name of NaCl? That's why it is called sodium chloride.
Right.
Okay. That's why it is called sodium chloride, because it is coming from hydrochloric acid. Hydrochloric acid. Acid is giving sodium chloride salt. I think you understood that. So what
Yeah.
is an ick acid? What is an ide salt? Okay. So suppose if you have HBr and by reaction with NaOH, it is giving NaBr. Then what will be the name of this beta? It is sodium bromide. So you have to end up always with ide. So is that clear?
Yeah.
So suppose if you have HCN and on reaction with NaOH, or let's say KOH, is giving KCN plus H2O. So what is this name now? It is potassium cyanide. You have heard of this potassium cyanide? Hmm?
No.
Well, it's very dangerous, right? So usually anybody who consumes this will immediately die. Okay.
Okay.
You're getting this? So what are ick acids and what are ide salts? I hope you understood that fundamental.
Yeah.
Now, first type of an acid is clear. Let us see second type of an acid, which is oxyacids. Like I told you, oxyacids are those which are not connected to central atom directly. They are connected via oxygen. So hydrogens are connected, H are connected via oxygen. Those are called oxyacids. So for example, I told you about H2SO4. If you see in H2SO4, the actual structure will be like this. Now you can see hydrogen is not directly connected to sulfur. It is connected via oxygen. So since it is connected via oxygen, we call them as oxyacids. Got it? So now every element has a different set of acids. Now we will first talk about nitrogen. When it comes to nitrogen, it has two oxyacids mainly. One is HNO2, the other one is HNO3. You will be learning about structure slowly as you go to the higher classes, but as of now, I'll give the structure myself. Okay, don't worry about sir how the structure came. Okay? So N double bond O and H. This is HNO. This is the structure. While here it is N double bond O and double bond O. And then you have another double bond O and OH this way. So this is HNO3. Okay. Next we have phosphorus. Phosphorus we have again two important acids H3PO3 and H3PO4. Well, it has one more acid. We have H3PO2. These are the three acids which you will see mainly. Structure wise, if you check it out, it is P double bond O. One is OH, the other two are H and H. Similarly, here it is P double bond O, OH, OH, and H. Here it is P double bond O, OH, OH, and OH. These are the structures of phosphorus acids. Then we have sulfur. Sulfur will have two acids majorly, H2SO3 and H2SO4. H2SO3, if you check it out, is S double bond O, OH, and OH. And if you see it here, it is S double bond O, OH, and OH. These two are the structures of sulfur. Okay. Next one is chlorine. Chlorine has a lot of acids. Right with this HOCl first. Here you have HO connected to chlorine. HClO2. You have chlorine double bond O connected to OH. You have HClO3, which is HCl double bond O connected to OH, and HClO4, so which is Cl double bond O connected to OH. These are the various acids which we have. Okay. These are something which you need to be very clear about their structures also going ahead and what kind of a naming they will get. Okay. Now let's see. First one. Now, when it comes to nitrogen, correct, you only have to check the number of bonds it has, okay, with oxygen. Correct. With oxygen, how many bonds it has? You getting it? Now, check this out. Between nitrogen here, check out the valencies. Valencies are based on the number of bonds here. So nitrogen is making 3 bonds here, correct? That means the valency is 3 here, right? So the valency here is 3. So I'll write it as 3. Valency here is 5 because it is making 5 bonds, correct? Right.
Yeah.
Here valency is 5. Here valency is 5, correct? Because it is making 5 bonds.
Yeah.
Read beta. But out of these valencies, these two hydrogens which are coming, if you check out these two hydrogens, these two hydrogens, they are actually not helping that acid, because this is the hydrogen, because the definition is hydrogen that has to be connected should not be directly connected, it should be connected via oxygen. That is the whole definition we are putting it. This is oxyacids, correct? So these are not acidic hydrogens. These two are not acidic hydrogens. You getting it? Yeah. So our idea should be only about how many hydrogens that are connected directly to via oxygen. So via oxygen there is only one hydrogen which is connected. Okay. So valence is definitely 5. Here also valence is 5. Here also valence is 5. Okay. But here it has 2 oxyhydrogens. Here it has 3 oxyhydrogens. In the first case, it has only 1 oxyhydrogen. I hope you understood what I'm saying.
Yeah.
Next one. If you see structure here, it has 4 bonds laid here. So which means the valency here is 4. The valency here is 6. Because sulfur here has 6 bonds. Okay. See the definition. First case. Nitrogen has these 2 acids majorly, correct? The lower valency lower valency uh, acids will always have suffix of us. Lower valencies will always have suffix name as us. Okay, so that's why if you see the name of this acid is actually nitrous acid. So I hope you understood.
Yeah.
Next, higher valencies will always have ic. That's why it is called nitric acid. So here it is an us acid, here it is a ic acid. Is this clear? So let me write down that here. Us is for lower valencies, ic is for higher valencies. Okay, beta?
Yeah.
Now here you have 2 lower, only one is higher, correct? One is higher, but the other 2, if you check out, these 2 have same valencies, but the number of OH groups are less, correct? So the one which has most number of OH groups, that is called as ic here, right? The lowest, other than that, it is us. This is also us. There are 2 us and 1 ic. Okay, but obviously we should not have same naming for both the acids, correct? Both can't be us only. So this one is clear that this is actually phosphoric acid. So this is actually phosphoric acid. I think this one is clear. But if you see these two are actually us acids. Okay. But to differentiate one us from the other, the one which has lowest number of OH, that will also have the name as hypo. This is the prefix name. So this would be the prefix name. This will be the suffix name. All right. So it is hypophosphorus acid. So I hope you understood that. So this is actually hypophosphorus acid. While this one is going to be simply phosphorus acid. It's going to be simply phosphorus acid. Now you understood. When you have high valencies, you will get ic. If you have lower valencies, you will get us. But if you have multiple us groups, then the lowest one we will always give it as hypo us. Hypo as the prefix name and us as the suffix name. Is that clear?
Yeah.
Are you sure?
Yeah.
Okay. See the next one. If you see H2SO3, In H2SO3, if you check it out, this is also there are only two ones. So here there is no problem. This one is us and this one is ik. Correct? So this will be sulfurous acid. Okay, and this will be sulfuric acid. Sulfuric acid. Okay, correct. Here we have two problems. There are four of them. So if you have four of them, these two are ic acids. These two are ic acids. These two are us acids. Okay, and we just learned the lowest one will always have hypo plus us. Correct?
Yeah.
And the last one, the highest of the ic acids, correct? The highest of the ic acids, we will name it per plus ic acid. So it would have a new prefix name which is per. Right? So now let us write what is the name for this. This would be hypochlorous acid. This is simply chlorous acid. Okay, this one would be chloric acid, while this name would be perchloric acid. So I hope you understood that. So if at all we write that again, this is HOCl, HClO2, HClO3, and HClO4. So how these are different acids, I hope you understood. Got
Yeah.
it?
Yeah.
So hypochlorous, hypochloric, chlorous, and perchloric. How it is to be added, I hope you understood. Yeah. So these are the acid forms. Now you should remember, okay, given any acid form, you must definitely know how to represent that. One second. Is this clear, beta? So given any acid, you should be able to name it. And now coming to the salts, okay. In oxyacids, salts derived from oxyacids, salts derived from oxyacids will have these suffix. What are that? Any acid which ends up with us, any acid which ends up with us, we call it as ite salt. Ite salt. Okay, and any acid which ends up with ic, we call it as ate salt. Got it? It's pretty simple actually. Us will convert into ite, ic will us convert into ate. Okay, so I'll show you how. For example, if you have HOCl, we just learned that HOCl is hypochlorous acid, right? Suppose if it was reacted with NaOH and it would form a salt NaOCl plus H2O. This is forming, correct? So it is NaOCl. This is the salt which is formed. So how do we name this salt now? This is going to be sodium hypochlorite. This is sodium hypochlorite. Got that? Okay. Acha. I'm sure you may have come across this. What is the bleaching powder? What is the bleach which we are using right now? You may have seen in the societies also right now. They are cleaning all the roads and everything with bleach. What is that? Where they are using? They are using this only, sodium hypochlorite, NaOCl. Where it has derived from? It has derived from hypochlorous acid. So hypochlorous acid, when you add it to base, you will get this salt form, which is NaOCl. Okay, so now given any molecule, you must figure out what must be its acid, what must be its base, Accordingly, what should be the name of the salt? So why the naming has come, I hope you understood that. Sodium, for obvious reason, because it is Na. Hypo, because it is the lowest valency chlorine. Then chloro and ite. Why ite is being used? Because all us acids will end up with ite salts.
Okay.
Is it clear, beta? Right?
Yeah.
Let me take one more example here. Suppose if at all I have HClO3. HClO3 name is chloric acid. Chloric acid. So if chloric acid is treated with KOH, which is a base, you will get this as KClO3 plus H2O. So what is this for now? This is potassium chlorate. Because it was an ic acid, it will end with 8. So KClO3 is potassium chlorate salt. Okay. If at all I have HClO4, then what will be the name here now? It will be perchloric acid. It is actually perchloric acid. So perchloric acid, if you treat that with NaOH, then I'll get NaClO4 plus H2O. So what is the name of this one now? This is sodium perchlorate. This is sodium perchlorate. So given any molecule, I think you should be able to figure out what should be the name that is going to come. So let me take one more, H2SO4 for instance. This is sulfuric acid. Sulfuric acid. Sulfuric acid, if you treat that with NaOH, we will get it as Na2SO4 plus H2O. Okay. Then what is the name of this now? This is sodium sulfate. Because it is an ic acid, it will end up with 8 salt. So it is sodium sulfate acid, salt. Got it? So any particular ic acid, that will always end up with 8 salt. Okay, I think given any salt, now you should be able to figure out what should be the name. Suppose if you have H2SO3 plus KOH, what is the salt you will get, beta? K2SO3 plus H2O. This is what you will get. Okay. So what should be the name of the acid? What should be the name of the salt? Tell me about that first. H2SO3. What is the name here?
Sulfuric acid.
Sulfurous. It is us acid. H2SO3, na? H2SO4 is ic. Right? These two, check it out. H2SO3 is us acid. SO4 is ic acid. So this is an us acid. So what should be the name of this one? Potassium. Huh?
No.
Potassium sulfite. Because us acid will always end up with ite.
Right.
Yeah. Us will always end up with ite. Okay. So if you have anything like HCl here, suppose if you have HCl and you treat that with NaOH, you are getting NaCl plus H2O. So I told you that this is hydrochloric acid, and this is sodium chloride salt. So given any acid base, first thing you must figure out what is the salt which is forming. Next, name that salt. Can you do that now? Let me give you a few questions like that. Suppose if you have HOBr and I treat that with NeOH, what is the salt I'll get? What is the name of the acid? What is the name of the salt? Similarly, H2SO4. I'm treating that with KOH. What is the salt which we will get and how to name it? Similarly, HNO3, treating with KOH. What do I get? H3PO3 plus NaOH. What do I get? H3PO4 plus NaOH. What do I get? Let us figure out on this. You try the first one.
Sulfuric acid.
Right. So this is sulfuric acid. And this one is
Potassium
potassium sulfate. Perfect. To the next one. Write the salt and water first.
KNO3.
Right. So it is KNO3 and H2O.
Yeah.
Okay. Name the acid and salt.
HNO3 is nitric acid.
Very good. It is nitric acid. Nitric acid. And this is? Tell me.
Potassium nitrite.
Nitrate. It is an ic acid. Ic acid will end up with 8.
88.
Next one. H3PO3. This is a very special case. So it should always be dealt with the structure. So I told you one thing. If it is H3PO3, the structure would be like this. It has only 2 hydrogens which are connected via oxygen. Okay. So it is not actually an oxyacid which can give 3 OH. It can only give 2 OH. So that if at all I treat with NaOH, so how many NaOH do I need? Because I need one H plus here and one H plus here to be replaced. So I need how many NaOH? I need at least 2 NaOH for this. Are you getting it up? So therefore the salt would be Na2HPO3. Because this H is not lost. This H is still there. Okay. Yeah. This plus 2, this plus 2 moles of H2. See what it is. Yeah. Okay. Now let us just recall what was its name here. What was its name? This name was phosphorus acid. Phosphorus acid. Okay. Now we are trying to find out the respective salt.
Sodium.
Right. So this is sodium. Sodium.
Phosphoric.
Phosphite. Because it is an us acid, it would become ite. Okay. But since there is one hydrogen in between them, so we can be more elaborative. We can write it as hydrogen phosphite. Sodium hydrogen phosphite. Even if you don't write hydrogen, still it is going to be the same name. But just to be more elaborative, you can always write hydrogen. Okay. Next one. H3PO4. I will help you with the structure. You have to do the rest. This one is the structure. So it meant I have to replace all 3 hydrogens.
Yeah.
So think about what should be the salt, what should be the name.
Phosphate.
Very good. It is sodium phosphate. So it is going to be sodium phosphate. I hope you understood that.
Yeah.
Okay. So these are some things which you need to practice immensely. Okay. So you need to be very, very clear about what are acids, what are salts, how they are named. Okay. Now, in this, if you will to add bases, bases are very simple actually. So let me just add on that definition. Bases. Okay. Any substance which increases OH minus ion concentration in aqueous solution. In aqueous solution is base. Okay. So for instance, if I take few examples, NaOH aqueous, KOH aqueous, correct? AlOH thrice aqueous, calcium hydroxide aqueous, MgOH twice aqueous, barium hydroxide aqueous. Okay, so these all are basic in characters. Okay, bases, the definition is simple, only one type of a base which you need to learn as of now. Okay? There are many different types of bases, but at least till you graduate up to 11th standard, you just need to know this much. All right. So NaOH, KOH, anything which carries OH minus, that is always going to be a base. Got that? And we learned that acid base will always have reaction to form salt. How do we name the bases? Naming of bases. Naming of bases is pretty simple actually. If you have, for instance, NaOH, the first name is definitely sodium, that is for sure. And OH is always read as hydroxide. Okay, is this clear? It will be ide, always ide. So therefore, if you have, for example, BaOH twice, that will be barium
Hydroxide.
barium hydroxide. You don't have to tell that it is a dihydroxide because already barium itself represent, it has two valency. So that is understood that they have to have two OH groups on them. Is that clear?
Yeah.
Now see this, very important thing is if you have an acid like H2SO4 aqueous and you are treating that with barium hydroxide salt, sorry, aluminum hydroxide salt, AlOH thrice salt. Got it? You always need to make sure all these hydrogens has to be replaced by OH, correct? Now you see I have two hydrogens, here we have three hydroxides. But number of hydroxides, number of hydrogens given and taken must be same always. Okay. So in that case, the way I can make them same is multiply here by 3 and multiply here by 2. So what do I get? So I will get 6 hydrogens here and 6 OH here. Are you getting that better? Yeah?
Yeah.
So therefore, what will be the name now? It will be Al2SO4 thrice aluminium sulfate. So you'll form aluminium sulfate and 3 moles of H2O. Got it? Not 3 moles, sorry, 6 moles. 6 moles of H2O. So the name is aluminium sulfate. Is this clear?
Yeah.
So these are the type of questions you must be able to do. I will give you list of questions now. I will put some questions. You need to figure out what is an acid, what is a base. You should write their names. You write their respective salt and name it. Okay. Can you do this task, Ritu?
Yeah.
Yeah. So I'll end up the session now. So I will put all the questions here and send it to you, and you can fill it in the same file.